Okay, so what do we mean by finding extreme values? We've done this before. We have used functions that we had to figure out what the highest value was within a particular interval, what the lowest value was within a particular interval. We've done that, and there was what we call an algorithm for doing that. But now we're going to do the same thing, but for trigonometric functions. So it means that I'm assuming a couple of things. I'm assuming that everybody was either present at our last class or has actually looked at the videos of our last class and knows how to derive a trig function. That's the first assumption. The second assumption, which is an assumption I'll always have to make, which is that you remember most of what you did in advanced functions, because that comes up in what we're going to be doing today. We're going to need to be able to solve trig equations. So those are two assumptions I'm going to make. I will show you how I solve trig equations as we go through this. This may not be the same as how you learn it in a different class if you had a different teacher, but I'll show you what I do. Okay, so let's get started. So we're finding extreme values, as I said, of trig functions. So by the end of the class, we're going to be able to determine the maximum and the minimum values of a trig function that is presented to us. And in every single case, it's not an unlimited or a domain which is unlimited. We're going to be looking at max or min values within a defined or limited domain. That's always going to be the case for what we're doing. And I'm going to remind you about some identities that may come up in today's class. And there's a handout for this, which if it's not on the website now, I may should put it on the website later on. But the reciprocal identities, the quotient identities, the Pythagorean identities, these, what we call the compound angle formulas, the double angle formulas, those may actually be useful at some point. In fact, I know I'm going to use one of them in one of the questions that we're going to be doing today. So it's important that you try to remember that stuff from advanced functions. Let's go. First question, we're going to go right into, we're going to just get started with the first question. What is the absolute extreme value? Now, extreme values are y values. Let me just remind you of that. So I want to know what is the, and it says absolute extreme, so it doesn't mean we're talking about necessarily a max or a min. It's both. So we need to find what is the highest value and the lowest value within this domain, from minus pi to 2 pi. Remember that minus pi means that I'm doing a rotation in a clockwise direction, whereas 2 pi means I'm doing a rotation in a counterclockwise direction. That will come up when we're trying to solve for the trig equations later on. But first things first, here is the function that we're going to be trying to find the extreme values for, the y values. Where is the biggest y that you're going to get between minus pi and 2 pi for this function? It's partially a linear function and partially a trig function. So that's what we're going to have to deal with. Well, as you know, when we're doing extreme values, or when we were doing extreme values before, one of the things we had to do was to find where you had critical points or turning points, or where there was horizontal tangents to the function. And that, of course, involves a derivative. So first things first, what is a derivative of this function? I'm going to stop and ask one of you to tell me what that is. Anybody? Give me a derivative for this function. What's my dy dx of the function on the screen? There must be somebody who can tell me that. Don't be shy. Come on. Is my mic muted again? Let me check here. No, it's not. So that means I should be able to hear you loud and clear.
I got 0.5 plus cos x.
Absolutely. There you go. So this needs to be set equal to 0 for us to get those critical numbers or critical points. So let's set it equal to 0, which would mean that the cos of x is equal to minus 0.5. There's no other solution for this one, right? If I'm setting this equal to 0, there's only one solution. Well, when I say more, there is more than one solution. Let me just rephrase that. But that solution has to be found within these boundaries between minus pi and 2 pi. Now, here's the way I do this. And again, this might be different from the way you were taught to do it. But if I know that the cosine of x is equal to minus 0.5, and I'm trying to solve for x, I'm going to say that the x is equal to the cosine to the minus 1, but I don't put minus 0.5, and I'll tell you why. When you go to the calculator and put in a cosine to the minus 1 of a negative 0.5, it's sometimes hard to interpret what that means. So I like to say, just find out what cosine to the minus 1 of positive 0.5 is. Now, you're going to have your calculator, so you're perfectly welcome to use your calculators to do that. It's one of those special angles, if you remember, from grade 11 and grade and advanced functions. It works out to be pi over 3. So here's what we're going to be asking you. Which quadrants should I be looking for that pi over 3 in? Well, here's a little diagram that I thought would be useful for us to figure this out. I always ask you to find the deviation from what I call the deviation from the x-axis. Here's my x-axis. I need a pi over 3 to be in the second quadrant and in the third quadrant. Why am I saying second and third quadrant? Because that's where cosine is negative. I was talking about a cosine angle, which was negative. So I need to go to the two quadrants where cosine is negative. And if you remember the cast rule, that would have to be second quadrant and third quadrant. So what I'm looking for is an angle between where I have this vector and the x-axis, which is pi over 3 radians. So pi over 3 here and pi over 3 here. Always measured from the x-axis. That's the way I look at it. So the question is, what is the angle if you're trying to get to these two positions, right? Pi over 3 from the x-axis in the second quadrant and the third quadrant, from minus pi to 2 pi. Now, if I start at 0, which is where I'm pointing right now, and I'm trying to rotate in a negative pi direction. Negative pi, remember, means I'm going a half a rotation. So if I do a half rotation going this way, right, I'm going to stop when I get to here. All right, I can't go any further than here to get to where I need to get to. I need to find out what is the angle measured from the x-axis if I'm going to be going and stopping here, which is pi over, remember, this angle between here and the x-axis is pi over 3. So I'm going in a negative direction to get to this line, this vector. Then I need to be pi over 3 away from the x-axis, but measured starting from the start, what they call standard position, starting from here. So what angle would that be going from here to here? That's the question I want to throw out to the room. All right, what is this angle right here that I'm creating going from 0 in a negative direction until I hit this ray, which is pi over 3 away. So this angle between here and here is pi over 3, right? Oh, I gave away the answers. This angle here, I didn't mean to actually click the button. This angle right here is minus 2 pi over 3, right? Because I'm not quite yet at pi, which is here. This is minus pi, I should say. I am pi over 3 away, so it means that from here to here is minus 2 pi over 3. So that's one of my answers for this, for the solution of this. But I need to get, and by the way, I can't get any more answers going in a negative pi direction because I need to get all the way up to here to get my other answers. But I can't get there with a minus pi rotation. A minus pi rotation stops right here. So I can't go any further going in a minus pi direction. To get my other solutions, I have to go in a positive 2 pi rotation. So I'm going to start here, and I'm going to go this way now, and I'm allowed to go all the way around until I get a full rotation. And in doing that, I'm going to hit the two spots I want to hit twice. I'm going to hit one here, so that's going to be one solution. I'm going to hit one down here, which is another solution. So the first solution, and I haven't given away this one yet, this first solution here is pi over 3 away from the x-axis. So what is this positive rotation going from the start, which is 0, all the way up to here? What is that answer? I need somebody to help me out with that.
So would it be pi minus pi over 3? So it would just be 2 pi over 3?
Thank you very much. Well done. And how about if I needed to, so that's the first one here, but I can still go further because this says 2 pi. So I can go past that first answer, go past pi, and I can go up to this other angle right here, which is in the third quadrant. What angle is that? So remember, I'm starting from here. I'm going past pi. I'm going another pi over 3 away to get to this other answer down here, going in a positive rotation. So what would that other angle be? So it would be pi plus this pi over 3, wouldn't it? Because there's a pi over 3 away from here to here. So if I'm going to go pi, which is a half a rotation, plus another pi over 3, what is that angle? Starting from here, standard position, all the way around to here. What is that angle?
4 pi over 3.
Excellent. So those are the two other answers that we need. 2 pi over 3, which was this one, right, to get from 0 to here, and 4 pi over 3, which goes from here to here. Now, within this domain, I have no more answers. So one answer was going in a negative direction, going this way, and that's where the minus 2 pi over 3 came from. The other answer came going in this rotation, a positive rotation. One was 2 pi over 3 the first time I hit an answer, and the second one would have been 4 pi over 3 the next time I hit an answer. So we now have 3 potential locations for us to have extreme values. But I also have to look at the 2 boundaries for my answers. Remember, part of the algorithm when we're doing maxes and mins within a particular interval, we also had to look at the 2 boundaries, because sometimes the boundaries are where you have your max or your min. So here are my places to look. I'm going to have to find the f of minus pi, which is one boundary, the minus 2 pi over 3, which is one of the x values, the 2 pi over 3, the 4 pi over 3, and the second boundary, which is at 2 pi. Unfortunately, this is a lot of number crunching. We're going to have to put each of these numbers back into my original equation. So I'm going to let you do that. Grab your, I hope you have your calculators. Take your calculator, put the 0.5x plus sine x in there. If you have one of those fancy Casios, then you can just keep using the same function and generating different values. Figure out what the value of the function is at minus pi, at minus 2 pi over 3, at 2 pi over 3, at 4 pi over 3, and 2 pi. These are where you have your potential maxes and mins. So let me go to the room and see if I can get you to help me out with that. I'm going to see who we have here and who I'm going to sort of target right now. Well, quite a few here. Let me start with Ashley. Ashley, let me start with you. Let me get my list here, 1 second. Okay, perfect. So I know exactly who is there. Let me go back to my presentation. Okay. Oh, yeah, Ashley, can I, oh, what did I do here? No, I went too far back. Okay, perfect. So Ashley, you're there, right?
Yes, I'm here.
Okay, I'm going to ask you to put the minus pi into the function and tell us what you're getting for that. Actually, what I'm going to have to do for a second here is just get a list of people on the side. Just give me 1 second here to just change my layout so I can actually see who we have in the room while I'm doing this. Just give me 1 second. So I'm going to do sidebar. Okay. All right, let's see if I can see who we have right now when I do that. I still don't have the, okay, I thought I'd get the list on the side. All right, I'm still trying to figure out this Google slide thing or Google Meet thing. Okay, so Ashley, you have some numbers for us?
Yes, when I plugged in negative pi, I got negative 1.57.
Okay, good. Well, I'm going to ask the rest of you, because I don't have the sidebar to see everybody who is in the room, just to go ahead and punch in those, because that's really what you have to do. It's kind of the number crunching part of this now. These are the numbers that you're supposed to be getting. The minus, and you do this for yourself. You're supposed to be getting the same thing that Ashley just said, minus 1.57, minus 1.91, 1.91, minus 1.23, and 3.14. Confirm for yourself that when I put these various values, and hopefully everybody understands why I chose these values, when I put all these values into the function, these are the y values that I'm getting out. So once I have all my y values, I can answer the question, because the question was, what are the extreme values? So I can now give a max and a min. All I have to do is just choose from this list of numbers what is the highest number and what is the lowest number. Remember, when it says absolute extreme values, we're looking for y values, right? It's not asking for the point. It's not asking for a minimum point, maximum point. It says, what is the extreme value? So I look at my list of numbers here, and it looks like my highest value would be at 3.14. That's probably pi. And my lowest value looks like it's at minus 1.91. So there's my answer. Max value is this, min value is that. Okay? All right, so that takes care of question 1 or problem A. I can certainly take questions as I go along, so feel free to just jump in if there's anything you want me to clarify about what we just did. If not, I'm just going to go right ahead to the next question. All right. Second question, minus 2 sine x plus cos 2x. And again, I have a restricted domain. I only want to know where the max value is, or min value, extreme values, between minus pi and pi. Okay. So the last time what we did is we found the derivative. Let me see if I can get a derivative from somebody here. Give me a second. All right, so Justin, help me out, please. Can you give me a derivative for the function that you see on the screen? When you derive that, what do you get? Oh, I saw that. Justin, you're there, right? I thought I saw Justin's name in the list. Justin, you are there, right? Well, maybe I'm not so sure. All right, anybody else? Give me a derivative for this, because I don't have the list ready at hand.
Justin put his answer in the messages.
Sorry, I didn't hear that.
Justin put his answer in the chat.
Oh, in the
His
chat.
microphone isn't working.
Oh, his microphone isn't working? All right, well, I'm going to have to go see that chat then. Let me see what he's got. Oh, you just read it out to me. What did he have? Can you read out what he has in the chat, please?
Yeah, he got minus 2 cos x, minus 2 sine x. No, minus 2 cos x, minus 2 sine 2x.
Perfect. All right, so there we go. Minus 2 cos x plus minus sine 2x times 2, which is what he's saying, basically, which is this thing right here. I'm just setting that equal to 0. And then I'm going to go ahead and factor out the common factor, which is minus 2. So I'm left with this. Cos x plus sine 2x equals 0. How am I going to solve that? Can anybody come up with any strategies as to how? Okay, one of the things we can do is we can divide both sides through by minus 2, which will make this minus 2 go away because it's equal to 0. Dividing both sides by minus 2 makes you, oh, geez, I should have given that away. I'm going to go back. Don't look at what I just put in. Divide both sides by minus 2, which makes just the bracket equal to 0. And if you can pretend that you didn't see what I just put in there, can you suggest what the next step might be for us to be able to solve this? Or maybe you already saw what I put in. How about the sine 2x? Is there an identity for that? One of the things I was pointing out to you is that your identities from advanced functions might come in handy. There is an identity for sine 2x, and it's this. It's 2 sine x cos x. So now that we have everything in terms of, it's a little difficult to solve when you have a 2x and an x in a trig function. But if it's all x's, just x's, not 2x or 3x or anything like that, then it's not that hard. What would my next step be now? Right? I have cos x plus 2 sine x cos x equals 0. I'm trying to solve an equation.
Can you factor out a cos x?
Oh, I like that idea. Let's do exactly that. So here's what we got. Cos x into 1 plus 2 sine x, and that's equal to 0. So what we're going to do now is we're going to set each of these equal to 0. We're going to take the cos of x and set that equal to 0. And I want you to remember that when you're talking about cosine, you're talking about your y value, sorry, your x values. So think about where, as you rotate through the space, so as I'm trying to find where x prime is equal to the cosine to the minus 1 of 0. I'm going to show you this little diagram here. Where would I have, cosine is my x value. Where is the cosine, where's my x value? 0. If I started off here and I had my, let's say this line was right here at 1, 0. My x value right now is 1. My y value is 0. So my cosine of 0 would be 1. When I get up to here, which is at pi over 2, Now my cosine value is 0, right? And so my x value is 0, my y value is 1. So it means that for pi over 2, that's the angle that I'm going to be looking for my cosine to be 0. For when my x value is 0, that happens when my rotation is at pi over 2. Again, this kind of stuff that we're doing now is stuff that we should have gone through in advanced functions. We just want to know what angle gives us 0 for cosine, and that angle is pi over 2. Now, look at where I have to find my answer. My answer has to come from minus pi to pi. So I'm allowed to go a half rotation in a positive direction and a half rotation in a negative direction. So I'm going to do a half rotation this way. I'm going to be able to hit my pi over 2. One of my solutions, which is here, should be possible because I'm doing a half rotation this way. My other solution is at minus pi over 2 because I can get another value of 0 for cosine at minus pi over 2. Again, I'm assuming some stuff that you should have learned in advanced functions. So I really have two answers so far for when the x prime is equal to cosine to the minus 1 of 0. One is at pi over 2. One is at minus pi over 2. I can't go any further to get any other answers. So I can only go a half rotation this way and a half rotation that way because of the limits of my domain. So I have two answers so far. But that only takes care of the cosine of x being equal to 0. But I should also look at this 1 plus 2 sine x being equal to 0. And this, of course, means that if I rearrange this, I'm going to get that the sine of x is equal to minus a half. And if you remember what I did the first time, I just said that the x prime is equal to the sine to the minus 1 of positive a half. So now we have to figure out which angle gives us a sine of a half, right? Now, again, this assumes the stuff that we did in advanced functions. The answer is actually pi over 6. So where do I put that pi over 6? I've already done that for you by putting it in the two relevant quadrants. I'm putting it in this quadrant, and I need a pi over 6 away from the x-axis here and a pi over 6 from the x-axis over here. Why am I putting it in these two quadrants? Because it says sine, and this is where sine is negative. Sine is negative. Remember, it had to be negative because the sine of x is equal to minus a half. It had to be negative in quadrants 3 and 4. Now remember this. I have to get to both of these two positions by going in a positive half rotation, positive a half, positive pi, that is a half rotation this way, or a negative rotation this way. Now hopefully you can see that I cannot get to these two positions by going a half turn in a positive direction. But I can get to these two positions by doing a half turn in a negative direction. So remember, I am pi over 6 away here and pi over 6 away here. So I need these two angles now. What angle would this be? And if I'm talking about getting over here, what angle would this be? Can anybody tell me what those two angles are? I need two angles that are pi over 6 away going in a negative direction and pi over 6 away going in a negative direction, but in this quadrant over here. What two angles am I talking about for those? Start with this one. What's this angle right here going in a negative direction?
Is that minus pi over 6?
That's the first one. Perfect. How about this one here? Remember, this is pi over 6 away from this. So I haven't quite made it to minus pi. I'm short by pi over 6. So starting from here, using standard position, and I have to stop here, what's that second angle? Going in a negative direction now. What's that second angle?
Minus 7 pi over 6.
Minus 7 pi over 6 means I've gone beyond minus pi because that would be minus pi and minus another pi over 6. So I haven't quite made it yet to minus pi. I'm short minus pi by pi over 6. So let's try that again.
Minus 5 pi over 6.
Oh, I like that. So there are my two answers. The minus pi over 6 and the minus 5 pi over 6. So those are my two answers. I can only get two answers by going a half a turn in a negative direction. I can get no answers going a half a turn in a positive direction because I can't get to these two positions. Let me just repeat. Why am I in these two positions? Because I need the sign to be negative, and sign is negative in these two quadrants, 3 and 4. And what angle am I trying to get? I'm trying to get a pi over 6 away here and a pi over 6 away here from my x-axis. And that's why the And by the way, this is not drawn to scale. I've just drawn two angles that are in the right quadrants, but they're not necessarily pi over 6 away. Just want to clarify that. Okay, so we have 4 potential places for answers, but we also have 2 more on the boundaries. So unfortunately, we have all of these numbers that we have to evaluate, from minus pi, which is the left boundary, the minus 5 pi over 6. I put them in order. The minus pi over 2, the minus pi over 6, the pi over 2, and the pi. So without us having to sort of pause to go through it, just understand that I had to put each one of these values back into the original function. Evaluate each of these values, and I want to get my y for every one of these values. So I'm just going to show you what the answers are, and then we can move on. So here are my values. I have 1, 1.5, minus 3, 1.5, minus 3, and 1. So these, starting with the boundaries, the minus pi and the pi, plus these critical numbers here, all of these are candidates for maxes or mins. So clearly, if you look at this, the lowest value is a minus 3, and the highest value is a 1.5. There are my answers. So my max value is 1.5, and my min value is minus 3. Done. Let's move on. How about this one? Cosine x plus sine x. Nice, simple function to derive. So again, I don't really remember all the people in the room, so I'm just going to go ahead and derive it. The cosine of x, the sine of, or sorry, the derivative of that is minus sine x, and the derivative of sine x is cos x. So here's our derivative. Minus sine x plus cos x. We're going to set that equal to 0. So cos x minus sine x is equal to 0. And now we're faced with figuring out what to do with this. How am I going to solve this? Cos of sine x minus sine x. All right, let's do this. Let's set them equal to each other. Does that help? Or is there something else that we can do to solve for x? I'm looking for some ideas here. Where is the cos of x equal to the sine of x? Where can I figure? I mean, apart from drawing a graph and looking at where the two intersect and going through all of that, is there another way that I could approach this? Any ideas? I mean, if they were all sine or all cosine, that would be nice, but it's not. So what do I do? No ideas from the room? How do I solve this equation? Trigonometric equation. Okay, let's try this. How about if I divided both sides by the cosine of x? Let's try that, see what happens with that. So this gets divided by the cosine of x, and this gets divided by the cosine of x. So cosine of x divided by the cosine of x, the sine of x divided by the cosine of x. Well, clearly this thing here is 1. This thing here is the definition of tan. So really what we're asking is, where's the tan of x equal to 1? So x is equal to, or x prime, I like to call it x prime, is equal to tan to the minus 1 of 1. So again, that's a special angle. Where is tan 1? Tan is 1 when you have pi over 4. And this was a positive 1, so I'm going to look for answers in quadrant 1 and quadrant 3. I need to be pi over 4 away from the x-axis here. I need to be pi over 4 from the x-axis in the third quadrant. And remember, I am going from 0 to 2 pi. It's all one positive rotation. So I'm allowed to start here and do a full rotation until I get back to 2 pi to get all of my answers. So the first answer, I'll just go ahead and give it to you, would be pi over 4, right? I mean, that hopefully is obvious. But my second answer is all the way over here in the third quadrant. So I'm going to go past pi and another pi over 4 to get to this second result. Can anybody help me with that second result? The first answer is pi over 4, right? Because I'm pi over 4 away. Pi over 4 here, pi over 4 here. What would this angle be going from here all the way around to here?
5 pi over 4.
Nice, nice. So there are my 2 potential maxes or mins. The pi over 4, the 5 pi over 4. Again, I have to add to that the 0 and the 2 pi. So my potential extremes are at these 4 points. And again, I just have to plug them into the original function, sine x cos x plus cos x. And these are the answers I'm getting: 1, 1.41, minus 1.41, and 1. Clearly, once I have these numbers, I can just insert them, and I can conclude that my max value is 1.41 and my min value is minus 1.41. Done. One last question. For this question, it didn't ask me for the extreme value. It just asked for the minimum, maximum point. And that means I need to give a coordinate, right? And I'm only, by the way, concerned with maximum, not minimum. And I have a very restricted range or domain. I'm only going from minus pi over 2, which is a quarter of a turn going to the y-axis in a negative direction, and pi over 2, which is a quarter of a turn in a positive direction. So really, I'm really restricted to only looking at pi radians from the positive side of the y-axis to the negative side of the y-axis. That's really the only place I'm going to be looking for my maximum point. So let's get to derivatives. It's 2x minus tan x. So for the people who remember the stuff we did on Wednesday, you know that this is a derivative, 2 minus sec squared x. The derivative of tan x is sec squared x. So there's your derivative. Set that equal to 0, and I have this. So that means that my sec squared x is equal to 2. Well, how do I solve for sec? I mean, I know how to solve for sine and cosine and tangent. But what happens when it's a reciprocal ratio? Are there any suggestions as to how I can solve this equation? Because this is where I'm going to get my critical numbers from. So do we have any advice for how I can solve this? Sec squared x equals 2.
Can you rewrite the secant squared x as 1 over cos squared x?
Oh, you mean like that? Nice. Okay, so 1 over cos squared x, the same thing as secant x, and that's equal to 2. And then why don't I just flip these two sides over? Because it's an equation. An equation means I can, do the same thing on both sides. I'm going to flip the two sides over. I'm going to flip this over, so it's just cosine squared of x. I'm going to flip the 2 over, and I'm going to get 1 over 2. So that represents the solution, sorry, the equation that I'm effectively trying to solve. Now, because it's a cos squared of x, it means I'm going to have to find the square root, if you look at this side over here, of the half. The cosine of x is equal to the square root, plus and minus, that's important to remember, plus and minus the square root of 1 over 2. And because the square root of the top is just 1, then another way we can look at it is just the square root of 1 over the square root of 2, really is what we're trying to find. Now, this is one of those special angles, and hopefully you remember that this angle that gives us 1 over root 2 is actually pi over 4. So the x prime of this is pi over 4. So I'm looking at pi over 4. But notice that I'm putting that in every single quadrant. And the reason I'm putting it in every single quadrant is because I am talking about the cosine being both positive and negative. I'm asking you for where this is both positive and negative. So I'm looking at all 4 quadrants. Now, I may not be able to get to all 4 quadrants based on the restricted domain that I'm looking at, but at least I know that the answers can be in all 4 quadrants. That's important to know. So remember, the angle that I need for cosine to be 1 over root 2 is pi over 4. So I need a pi over 4 here, a pi over 4 here, pi over 4 here, pi over 4 here. Unfortunately, because of the restriction of the domain, I can only get as far as here and as far as here. I'm going a quarter of a turn this direction and a quarter of a turn in this direction. That's it. That's all. I'm not going to be able to get to these two sides over here. I can't reach there based on the limited domain that they've given me. So I can get to this point and I can get to this point. So this angle here should be my pi over 4. Hopefully everybody can see that or can recognize that. And this angle here should be my minus pi over 4. So, oh, did I just say pi over 4? Huh, it's pi over 3, sorry. I take that back. Somebody probably heard me saying that and didn't want to embarrass me by correcting me. It's okay. Correct me if I got something wrong. So this actually should have been pi over 3. So we now need to figure out where to put that pi over 3. Let me just double check that. I'm pretty sure it's pi over 3. Cosine to the minus 1 of 1 over square root of 2. It is pi over 4. Why do I have pi over 3? Why do I have pi over 3 here? 1 over root 2. Yeah, I'm going to have to review this question again at the end. But let's just say this was pi over 4. I don't know why I have pi over 3 here. Cosine of minus 1 of 1 over root 2 should be pi over 4. All right, so amazingly, somehow down here I ended up with a pi over 4. So this line here, there's always some mistake in there. This line here is wrong. It's meant to be pi over 4. So I need to put my two boundaries in, which is the minus pi over 2 and the pi over 2. So those two boundaries are in. But then I have the minus pi over 4 and the pi over 4 as the two, I guess just ignore these numbers here, as the two other points that I have to check. That's where my potential maximum value is. So I'm going to go ahead again and put those values in. I'm getting infinity, minus 5.7, and positive 5.7, and infinity. Now, I cannot get a local max where the function doesn't exist. It's infinity. It's undefined at that point. So I'm not going to use any of these, the minus pi over 2 or the pi over 2. So it's going to be one of these that would be my answer. So I'm going to therefore assume that since I want a max, it's going to be the positive 0.5 over 7. So my max point occurs at pi over 4, which is what gave me this, right? The pi over 4 is what gave me the 0.57. Pi over 4, positive 0.57. And that's it. So that's it. That's all. I'm done.